Hi, welcome back to AT Math. Today, 4-5 scatter plots and trend lines. Why this information is more important than brakes on a buggy. Okay, scatter plots. Basically, what you're doing is you put all the data dots on a graph and see if there's a relationship. In other words, you're comparing one thing with another and you're trying to see if there's a pattern or something you can predict over time. Take a look at this table. They're saying new animals that were put on the endangered species list. Well, they take the calendar year, which was 96, 97, all the way to 02, and they said, well, 96, 91 species were put on the endangered species list, 79, 62, 11, 39, 10, and 9. That doesn't tell us much, but let's look at the table. What I suggested that we first make the table using the item name on the bottom and this amount of them on the side. So you can use either way, but for me, I like an amount I'm going to count on the side, and then like the item data or the year or whatever's on the bottom. That's just me though, but the countables I usually put on the side. So I'm going to put the increase in species list. So if you notice, in 96 they were 96, 91 excuse me, then 79, the 62. Now these dots do not form an exact line. That's true. But overall, do they show an increase or decrease over the years? And I think you'll see that overall, while not perfect, it definitely shows a decrease. Now, we can argue as to why there's a decrease. Was there a decrease because we were better at conservation and there was less animals that were harmed or put in danger? Or was it a case where there simply weren't as many cataloged? Or the ones that were already on the endangered species already the only ones available that were really in endangered? So it's hard to say. But with this data, we can start formulating possible opinions as to why. Now, if you look here, so now we want to see if there's a correlation between the number of species put on the endangered list and the year. Is the number going up, down, or is there no correlation? Clearly, if I make a line, you see it's going down. So as the years go on, the number seems to be going down. Therefore, it is a negative correlation. Now, this average line you draw is called the trend line. This trend line doesn't have to connect a single dot. It just shows basically how they're going. Again, you don't have to run through every single dot for it. You're just saying this is the general direction. But you want to have it kind of in between. If I had like the trend line way over here, well, I guess I can't do that. But if my trend line was, like going from here over here, but all my dots were here, that wouldn't be well representative of what I'm trying to do. So you want to have your trend line in between the dots as best you can. Here are three correlations. First, you have a positive, which is right here. It goes from left to right. And as it's going from left to right, it's going up. So as you can see, it's on the way up. Negative correlation means on the way it's going down. So those are easy. Positive, negative. And it's true because you can clearly draw a trend line through them. But let's say you have this. Well, I can make a line this way, but I can make one this way, or this way, or this way. And the problem is there's no exact direction. So we'll say in this case there's no correlation because I can't determine where the lines are. Last thing. When given a scatter plot, you may be asked to give your opinion as to what's going on and why. So in this case here, I don't know. Let's say the U.S. national debt owing trillions of dollars. In 2000, it was $6 trillion. In 2002, it was 7. 2004, it was 8. 2006, it was 9.5. And in 2010, actually 2000, and that's not even correct because that's actually in 12, it's 16 trillion. So it keeps doing this. So the question is, what's happening here? As we can see, obviously the debt's increasing. Now you can argue as to why: government spending, lack of revenue, whatever. But it points that there's definitely a sharp trend. Now this was, of course, from 2000 to 2010. Doesn't really show much of a spike. But look at this here. The debt was almost non-existent. Now, to be fair, the last time we paid off our national debt completely was with Andrew Jackson. So, there's been debt in the U.S. for a long time, but if you notice, it didn't really spike until about the 70s, and then booyah. We went from $400 billion to now it's well over 16 trillion. So clearly someone in Washington better figure something out, because there's a giant spike in that. And so this trend line helps us identify, like, whoa, what's going on here? So based on this graph, what might this lead you to believe as far as, well, in this case, the U.S. debt limit? Might be something you want to talk to your social studies teacher about to get the word. But I'll leave you at that. As far as the notes go, we're done. Homework-wise, a couple quick things. How is a scatter plot that shows no correlation different from a scatter plot that shows a negative correlation? No correlation could be going across the board. Negatives going down. Does a trend line always pass through every point in the scatter plot? No. Trend line doesn't have to touch any dots. It just has a general path. So describe the correlation illustrated by your scatter plot. Looks like this one basically is going up, so I'd say positive. This one's basically going down. You'll have homework tomorrow. It's a quick notes today. We are done. Thanks. Bye.
We got an order to do? I want a quarter pounder minus pickle and a Big Mac. You better get that right, no coke. Just give me Sprite and don't forget the Big Mac sauce on the side with the extra fries. I'm so hungry it's like I haven't eaten in days. Oh yeah, don't forget the mayonnaise. I like it on the side. Got Hamzy on the side. Got Monster in the back. We going for a ride. Don't get my order wrong. I don't want to come back in this drive-thru. Gonna get a fillet of fish with that. I'm a chicken on the side too. You want an apple pie? Hold on, just make it two. Okay, let's go.